Alrighty, so topic 8 is talking about linear inequalities. If you feel confident in graphing just normal linear functions, then this should really be no big deal because they're very similar. And we're actually going to start with a review of just a normal linear function. So y equals 3x plus 4. We graph that by first putting our y-intercept on the graph. Then we use our slope of 3 to create our points on the rest of the line. Remember that 3 can always be placed over 1 to see the true rise and run. So from my y-intercept, I'm going to go up 3 and over 1, draw my next point, up 3 over 1, draw my next point. I can keep the line going the other direction by going down 3 into the left 1, down 3 into the left 1, over and over. Then I just connect those with a line. Okay? Again, that should just be a review. So you'll notice the next one they want us to graph is very similar. Y is greater than or equal to 3x plus 4. The right-hand side of this inequality is the exact same, and we're going to graph it the exact same way. So I'm still going to start with the y-intercept of 4, and I'm still going to use a slope of 3. However, I want to show that y is greater than or equal to that line of points. Okay? So if I draw a line here, I need something that denotes that it's not just this line of points that will work, but there's actually an infinite number of points that will make this inequality true. Remember, that's what inequalities are all about, is actually there's an infinite number of numbers that can be plugged in so that the inequality remains true. So the way we do that is we shade. So I'm going to shade everything above this line. So you'll notice I'm coloring everything on this side. Now you may look at that and say you didn't shade above, you shaded to the left. However, the way I read this inequality is I'm reading it as y is greater than or equal to. Sorry, that's an underline, that's not equal sign. Y is greater than or equal to. So I'm going to focus my eyes on my y-axis, and I'm going to go to my y-intercept. There's my y-intercept. This y that I'm wanting to find is greater than my line. Greater means I'm going up on the y-axis, so I'm going to shade above that y-intercept. It just so happens that when I start shading above, that also means I need to shade all of this other stuff as well. Okay? So let's try it again. Over here. Y is less than 3x plus 4. The line itself is formed the exact same way. So I'm still using a slope of 3, still using my y-intercept. One thing that's different about this one is that I have y is less than, not y is less than or equal to. The way I show that on my graph is by using a dotted line. Okay? I still need to shade, though, to show all the other points. So if y is less than, that means I'm going to go to my y-axis, because I'm talking about y. I literally said the word y. And I'm going to find my y-intercept right here, and I want to shade less than that point, which would mean down the y-axis. So when I go to shade, I'm doing all this part of my graph. Yes, it's also to the right a little bit, but the main thing is that I went down the y-axis. Okay? So let's just kind of recap, and then I'll explain a little bit of this in more detail, and it might make more sense. So less than. When you have less than on your equation, or inequality, I mean, y is less than blah, 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 that means that you need to shade below the line, and you need to make sure that you use a dotted line, okay, because it's not equal to. When it's y is greater than, you need to shade above the line, but still use a dotted line. When y is less than or equal to, you're back to shading below, but you need to use a solid line when you actually connect your points. And same with this one. When y is greater than, you do need to shade above, but again, you need to use a solid line when you connect your points. Okay? So, if it's equal to, solid line. If it's not equal to, dotted line. Or dashed line, however you want to say it. Okay, so let's practice some more. Number 1. Y is less than 4/3 x minus 4. So y-intercept is negative 4. I'm going to go graph that first. Slope is 4/3. So I go up 4 over 3. Up 4 over 3. Now, this is y is less than, so I need a dotted line. I do not want to just connect them with a straight line, or that would be equal to. And now I need to figure out which way I'm going to shade. Well, y is less than. I'm reading this, y is less than. That means y, so my eyes are on the y-axis, is less than. I'm going down the y-axis. So when I go to color, I need to start down there, and then I can kind of fill in the rest of the graph, which in this case is a little bit to the right, but the focus is on the y-axis and the fact that I went down. So now, here's the big question. It says, is -2, 3 a solution? So the way we use these graphs that we're making is by plugging in potential coordinates to see if they make the inequality true. Well, visually, we just tested on the graph. Is -2, 3 a solution? Well, I go to -2, 3, and I draw that point. You want it to be in the shaded region. So the answer here is no. That's not a solution to this graph, or this line. Okay, is 6 -2 a solution? I go to 6, -2. Is it a solution? Yes, in this case it is, because it is in the shaded region. Okay. The way you would further test this, which we'll actually do on the next part of this notes, is by plugging it in. So again, our inequality is y is less than 4/3 x minus 4. If I plug in the xy from this coordinate, so I've got -2 is less than 4/3 times 6 minus 4, it should be a true statement because it was in that shaded region, right? So -2 is less than 4/3 times 6, that gives me 8. 8 minus 4 is 4. Well, is 4 greater than -2? Yes, that is a true statement, which makes sense because the point was in the shaded region. Okay, I could do this again with the other point. I could plug in -2, 3, and it should come out to not be true. So I plug in a 3, plug in my -2. So 4/3 times -2 is -8/3. Minus 4 would be -4 8/3. Is anything that's negative greater than 3? Well, no, that's false, which makes sense because it is not in the shaded region. Okay, so yes, you could just plug these into the inequality over and over and over and just do the math. However, graphing it gives you a better visual of all the points that you could work. So let's do this next one. Again, start with your y-intercept. In this case, it's -4. Do your slope of 5/2. Connect those with a dotted line because it says y is greater than. I need to shade. I'm going to focus my eyes on the y-axis, the y-intercept, and it says y is greater than. So I need to go up the y-axis. So I'm going to shade this way. Okay, so then it says, is 1, 1 a solution? Well, I'm going to go graph 1, 1 right there. Yes, it is. It's in my shaded region. Is 2, 1 a solution? Well, that's on the line. In this case, the line itself is not fair game, okay, because this line is dotted. If it was equal to, if it was a solid line, my answer would be yes. But in this case, it is a dotted line, so the answer is no. Okay, all right. One more on this page. The first thing I would ask is, what do you notice about this inequality? Well, I can't find the slope or the y-intercept when it's written in this format. I need this to instead say y is greater than or equal to, whichever one, mx plus b, which I do not have. So I need to do some rearranging here. I'm going to add my x to both sides. So -2y is less than or equal to x minus 8. Then I need to divide by -2. Well, what do we remember about inequalities? When you divide by a negative, your sign flips. So I've actually got y is greater than or equal to. Then I complete the right-hand side. So remember, this is an imaginary 1. So I've got -1/2 x plus 4. That is the inequality that I'm going to graph on my graph. Okay, so just move this out of the way. Y-intercept is 4. Slope is -1/2. This is equal to, greater than or equal to, so I can actually draw a solid line this time. That was a horrible solid line, sorry. Yay for notability. Now, if it's greater than, I'm going to put my eyes on my y-axis and go up the y-axis. So I'm going to shade above it, and now I can test my points. So is 0, 4 a solution? That is on my line, and because this is equal to, the answer this time is yes, because the line was solid. It's equal to. Is -3, 5? That's right here. It's just barely south of the line, so the answer here is no. So this is a lesson in being detail-oriented when you're drawing, making sure that you are precise, because if somebody just kind of wiggled their line just a little bit, they just kind of got carried away and kind of did one of these kind of things, they might accidentally include that point when really it should not be included, okay? So the answer there is no. It is not included in that solution set. Alrighty, so if you at any point want to pause this video and work ahead of me, please do so. I'm just going to continue talking through these remaining, however many, let's see, 6 problems. But again, feel free at any point to pause, fast forward if you feel like you're getting it. So number 4, 4x is less than or equal to negative 4. Again, I need this to say y equals mx plus b. But wait, there is no y. So the next best thing is for me to get x equals. So I'm going to divide both sides by 4 here, and I get x is less than or equal to negative 1. Well, I recognize that as a vux. So this is just a vertical line at negative 1. It is going to be a solid line because it is equal to. But this time, when I read this to myself, it's actually different. It is x is less than or equal to negative 1. So I'm going to focus my eyes on the x-axis and go less than or equal to. So I'm actually going to shade straight up to the left this time. It's not even at a slant, so it's not really above or below. It's really and truly just to the left of the graph. So now they're wanting us to come up with 2 solutions. So I just need to pick 2 points that are in this region. I could pick things on the line. I could pick things over here. Honestly, I could pick things further even off the graph as long as I'm sure that they are to the left of that line. So I'm going to use one of the points on the line itself. So I'm going to say negative 1, negative 3. And then just for kicks, I'm going to do one that's off the graph. I'm going to go with negative 80, 400. I'm guaranteed for that to be to the left of the line. Okay? So number 5, first thing I notice is this is not in slope-intercept form. So I need to add my 3x over. So 2y is greater than or equal to 3x plus 12. I need to divide by 2. So y is greater than or equal to 3/2 x plus 6. So then I need to move all this over here. Put my y-intercept on there. Now 3/2, I can't actually go up and to the left because there's no more graph for me to look at. So I'm going to go down and to the left, or up and to the right, sorry. But now I'm going to go down to the left. Okay, solid line because it's equal to. I'm going to be shading above because it says y is greater than. Oops. Name 2 points that are not solutions. So I'm going for points that are out here in the white space. Okay, it could be any 2 that you want. It could be the origin, right? Because that's not in the shaded region. It could be that other point I did, 4, 2. Obviously, there's an infinite number of answers that you could put as your answers here. Okay, last one here. Again, I wanted to say y equals mx plus b. So I'm going to divide both sides by 2, and I get y is less than 5. There is no x here. There's no slope. So that means that this is a hoi. This is a horizontal line. So I'm going to go to 5, and I'm going to draw my horizontal line. In this case, it's a dashed line, because it just says y is less than. And when I shade, it's very clear. I'm looking at the y here, and I'm less than. It's just down. It's not right and left at all. We're just shading down. So name 1 point that is a solution and 1 point that is not. So I'm going to say the one that is the origin, just for fun. 0, 0 is a solution. Okay. The one that is not, I'm going to name something on the line because it's a dotted line. I can't actually use the line for my solution set. So I'm going to go with that one. 4, 5 is not a solution.